Good day, I'm Dr. T and welcome to my office. So let's talk about liquid-liquid extraction. This is a classic way of separating out a mixture and getting two different chemicals away from each other. So in this case, we're going to take two solvents and they need to be non-miscible or immiscible solvents. This way, we're going to put them together, we'll shake them up, but they will separate out and we'll get two layers. Now, here's the beauty when you do this. If you have a mixture in one solvent, but some of your molecules have a fairly significant preference for the other solvent, then they will travel to the other solvent when you shake it up. Once they separate, you have now separated them, and you can simply extract off the one solvent from the other, and boom, you've got yourself a separation. Typically in the lab, we use a separatory funnel, which is a pear-shaped flask that has a stopcock or a valve on the bottom that allows us to drain off the bottom of the two layers. In industrial scales, there is more complicated apparatuses in order to do this at very high volumes, more so than what you could put in a flask that you hold in your hand. There's also a few variations on how you can do this. So obviously the simple one would be you take typically non-polar solvents, something like hexane, and you mix that in with some water or some alcohols, typically something more like a water, and you have this nice polarity difference. That's why they're going to be immiscible. You shake them up and the chemicals just move. But you can get a little bit fancy. If you, say, have an acid that you want to get rid of and it's in your organic solvent, so your non-polar solvent, then you could add a little bit of base that's going to deprotonate it, shake it up, and that's going to make it much more tempting because it's now a salt. It's going to make it much more tempting to go ahead and move over with the water. So there's a couple of ways you can do to kind of kick this up a notch and improve your separation and fine-tune this approach. But a very common technique that as chemists we use. So with that said, have a wonderful day, and I'll see you in later videos.